That ain't gonna work. Oh. So I need to scoot this down. Should be it. That's what we need. Alright. Sorry guys, I'm trying to figure stuff out while also trying to make this whole setup work right now. Alright. Let's get some ends real quick. I need those right there. I need to look up and see if I need another one. I might have to grab another one. I might be out. I don't know. I'll rotate that over there. Let me hop in these lives real quick. This camera needs to be over here. I need to refresh that one. Click on the live. Click that live. I need to click. Pull this up here. Click my RF supply. Click that video. Click that video. Pause that video. Alright, TikTok. I clicked the live, but I'm not. Tell that's to play at the lowest quality. Real quick. Settings. Quality is the lowest. We're good to go. What's up, Get Low? Doing well, man. So I'll scoot this over here. I got comments available. YouTube land over here. Dismiss. Dismiss. Click this. View that. And click the live. Pause video. No thanks. Alright, pull this over that way so I can see what's going on. Now I gotta drag all this stuff back up. Only bad thing about having all this stuff, it's not super bad, it's just it takes a little bit of time to get all this crap lined up right. I see my bit rate though, that's pretty cool to know. Wider. Let's see what's going on. We don't see no drop frames. Alright, cool. I wish this would go smaller, and it does. Alright, let's get to work. So we're working on some 1/2 inch hardline right here. I've got a weird position that this is in. So I gotta make sure I'm not gonna damage a wire that I got over here. So get to work. I need my skizzers. They are currently hiding up underneath this cutter right here. If you guys got questions, I think we've got audio. Let's go over to my sound on my audio mixer. Yeah, we got sound. We're good. What's up, Get Low? What's up, Huck? What's up, user? Hope you guys are doing well. We got stuff to cut, stuff to work on. So I am currently building right now. It is late over here, but we got stuff we got to get done. So I'm trying to get it done. Zero bugger. Calls for a total of, let's call for 33 or 28. I need to know. Let's check and see if we're on a high edge. We are. It looks like it right here. I'm gonna cut Let's back real quick because this is on this piece. It don't matter. So for you guys that can't see the video, looks like Facebook is froze. What's going on? So let's go ahead and reset that. Sorry, YouTube and Facebook. I'll get you guys fixed in just a moment. I didn't know it was froze. You guys didn't tell me a dang thing. I'll be back. It would have been a lot nicer to know a while ago, but... Killed the camera. And let's pull up the camera link. It's going to be camera hub right there. Minimize this. Click that. Oh, where the heck is it at? Yeah, it's late. I'm trying to figure out where my camera hub is. Give me just 1 second. We're trying to fix this junk app. Open the camera hub up. Let's see where camera hub's at. All right, so what we're working on right now, OBS. See how I got the view on the big camera, but I don't have the view on the small camera? Let's go to sources, properties, cam link, it's okay. Hey, I'm back. All right, cool, whatever. It doesn't matter. Let's get to work. Yeah. So I've got several orders that I've got to get finished. So currently I am trying to get caught up. I was under the weather last week, so it was a weird sickness, man. It's still not done, whatever the heck it is. But I'm grateful to be going towards the upside of it, kind of getting beyond whatever the heck it is. But I guess I'll figure out soon enough. Hope you guys can make it to Gulfport. If you guys cannot, then I will hopefully see you at the next event. Wolfman event is the next one. There's Wolfman CB Shops having a big swap meet. That is October the 25th. If you guys can make it out. I don't know if I'll be live at that event. That's the one event that I do stay pretty busy at, trying to do work and trying to get stuff done. All right, now, hello, hope you guys are doing well. So now I need to cut this. I need to measure real quick. This is going to be kind of hard to hit at the right spot, so I'm just going to hit it right here. Let's get my tool and get to work. What's up, Hollywood? Hope you're doing well, man. Make a mark real quick. Can you guys on TikTok land see what I'm doing? Let me see if that video's paused or... Yeah, no, we're good. You guys are in a pretty good shot. You guys can see everything over there on TikTok. All right, we're working on some 1/2-inch hardline. This is, we're going to put some 7/8 EIA connectors on it. So I'll let you guys see. If anybody is not familiar with what I do here, I purposefully work with your general hand tools on these parts, simply so that you guys can see how to do this yourself. This is not for me building this wire and stuff. Like, I could build it pretty quickly all on my own, but the whole point of these videos is to try to help you guys out. It's not really being cocky. I've got the tools to be able to do these things. Also, if I'm being super particular, I do like doing it my way better than what their tool offers anyway. So keep that in mind if you plan on using the tool. Let's measure this boogered back real quick. What's up, Tony? Hope you're doing well. Hello. TikTok is going nuts. Hope you guys are. If you guys don't know what this stuff is commonly used in broadcast. So if you're running, say, a cell phone or something like that, and you want to figure out what the heck they do, this is what they put on cell phone towers. If you're, let me measure this out to 7 mils real quick. If you've heard your FM radio before, this is the same stuff they put on the radio towers. So this is just a coaxial cable. It's used in a lot of different applications. So if you got a cell phone, if you've got a AM FM radio still, then you are somehow reaping the rewards of this material being here. What's up, Hambone Jr.? Hello, Candyman. Hello, Michael. Hello, Fredalicious, Christian, and all you guys hopping in here. Hope you guys are doing well. We have, like I said, an EIA connector to do. So if you guys are not familiar with an EIA, it is a type of termination that uses bolts. So, all right, yeah, we're working on, like I said, some 7/8 EIA connectors for some 1/2-inch hardline. I've got to do a couple more things of prep while I'm putting it together, and that's just basically making sure it's sealed from outdoor, sealed for outdoor use, excuse me. So I'll cut that one off. We'll use our material right here. This is just like it's the same thing as a dielectric grease. It's just a silicone grease compound is all they use. So making sure the O-ring is nice and greased up, so we don't have to worry about that O-ring binding up when we tighten this connection up. So look in this hole right here. I don't know if you guys can see it. Where's my camera at? Let me turn this camera over just a smidge for Facebook land. TikTok can see it just fine. But look in there. We got to line this up. We got one little edge to bend over. A smidge more. There we go. What's up, Trapper? That doohickey that fits right up on the toilet, right? I know, right? Toilet flange. That's what this is. All right, so it's the thingamabob. Hello from Puerto Rico, WP4Z. Hello. Hope you're doing well. So we're going to go ahead and build this flange. I've got to flare this connection out, and then I've got to put this basically retaining ring on here. So what I'll do is take my little needle nose right in here. All right, and then I build my flange right up inside this edge, flare that connection out. I gotta push the foam or the dielectric back to the middle. This is a foam polyethylene. That's why I call it foam. That is the dielectric material they choose to use on all of your non-air cord Heliax cables. So if you get any cable branded Heliax from the Andrew Company, Andrew Corporation, then you're either going to get air core or you're going to get foam polyethylene for your dielectric material. I think Plenum might run something a little different. But I'm pretty sure it ran a foam polyethylene too, because I've had some Plenum too. I'm not sure about the larger Plenum though. So, all right. Let's get to work. I need to clean up this. Right, y'all. Any questions while we're working on coax, you guys can ask. If you want to know what the heck a daggum radio station is, if you want to know about FM radio, if you want to know about your cell phone stuff, if you want to know how the heck this ties into that, if you want to know what the heck a coax is, questions are okay. I had a bunch of people hop in from TikTok and then they all ran away. I appreciate the guys that want to stay. All right, so flange is made. Let's go ahead and go inside and push this dielectric material down just a smidge, so it's going to be out of our way all the way around. There we go. Line up our connection right here. I just thought of something. Shouldn't have to be cut back. If I have to, I'll cut the jacket back, but I really don't think I should have to, because it's according to the measurement. There we go. That's all I needed. It just didn't slide all the way up. That's all it was. So this needs to stay still, and I need to rotate this on. So you guys can see what I'm doing pretty much, but it's pretty critical that I don't cross thread right here. So I got to make sure we're lined up straight. What I typically do to do that is kind of go in reverse before I go in forward. All right, so I'm cheating a little bit just because it's almost. I love these things for connections that go on a little bit different than these, but for this one, there we go. It's just a little bit more of a pain. It's a very hard pitch, very few threads. It turns maybe one full turn, and then it's locked into place. So it's very, very difficult to get it started when you got a wobbly. The wobblies are great for other stuff, but not for that. That's the one thing it's irritating with. So the goal from here is to try to pull this connection off. If you can pull it off, you didn't put it on right to begin with. So there's that connection there. Now from here, we're going to go ahead and do the next piece. So I need to look real quick, take a moment, and follow this cable down. So I'm going to lift this cable up so you guys can see it while I'm following. So cable. Fingers touched. Good. Follow it all the way around. Make sure I'm on the right piece. This is the right piece. Okay. So now it's pretty particular for me to do this next step. Ugh. I hate to do this, but I'm going to do it anyway. There we go. That's what I needed. And now, from here, I'm going to do something a little odd. You guys are not going to really understand it, but it's important for what I'm doing. Alright, knife. Knife. That's not a knife. That's a knife. Alright, got a first in. Let's zoom a little bit for you guys. What do you guys on TikTok think? You guys want to get in a little bit closer to this to the scene where you guys can see better? Thanks for the share, Hambone. I appreciate you, man, for sure. What do you guys think about this camera angle? You want to come in a little closer, or you guys like it where it's at? Hey, John, thanks for the share. Appreciate you, man. So we are currently working on some 1/2-inch hardline, and right there. Ah, that's gonna be a little annoying. I should have. I'm gonna go to the next one. We're just gonna give up 2 millimeters. I will survive. There we go. Actually, 3 millimeters. So I gotta go 3 more millimeters down. I'll measure. I'll just do it now. Whatever. 3 mils down. So 36. 36. There we go. Now, let's take this right here. We won't do that. We'll do this one first. So I've shown you guys on a few occasions how to build these. But what I'm doing now, I think I zoomed in too much on Facebook. I'm regretting it now. Not because I've done anything special, but simply because I'm at an angle where you guys, I don't think, was able to see that. Maybe you saw most of it, I don't know. TikTok saw everything. All right. You know, we're programmed to want to see a little closer, sir. Let's zoom in real quick. Let's see how this works. I'm super delayed on TikTok, so we'll try that real quick. Maybe that'll work. Let me see how close it zoomed in. Did it work? Hey, it worked. Okay, cool. So we'll bump the camera over just a smidge, and I think that should be good enough. So let's change the brightness over here on YouTube and Facebook land so you guys can see better. What do I have working on here? We're working on a 7/8 hardline. We're doing a 1/2-inch hardline. We're doing a 7/8 EIA flange to it. That's what we're currently working on building. I've got to cut back my jacket. And there we go. So try not to get too aggressive when you cut the jacket back, because you can cut into the corrugated copper right here. From here, I'm going to put this on that connection, right? Let's go ahead and get our rubber O-ring on. That's going to be inside this baggie right here. I've done a few of these, so forgive me for not explaining more. If you guys would like more of an explanation, we can go over what I'm exactly doing and how I'm doing this stuff, because that's what these are. They're kind of like a tutorial video for you guys to learn. That's what they're styled as and what I've been doing for years. Give me just a second to clean up my mess. I got a little bit of these baggies take up some more room on my bench, and if I can clean it up, it'll look a little nicer. That can stay over there. That'll be fine. I got one inner bullet. I got another inner bullet over here. So, camera angle's pretty good for TikTok. Camera angle's pretty good for Facebook. Yep, so if you look right here, this is bulletin number 237903. That's what it is. So you're learning about positive stop connectors is what this is. All right, so let's take a look real quick. I sell these things so you can buy them from me if you like them. All right, next we've got to go ahead and cut the body right here. And what I like to do is I will take half of it and just get a hold of it with some pliers. It pulls it off nice and smooth. All right, Sourdough Dad, thank you for sharing the live. I appreciate you guys. You guys are cool. Samir, I am sorry I cannot translate over here. I don't know how to. Let me go right here and see if it lets me translate. Right here, it does not. That's very annoying. I wish I could see I can see a comment, but it doesn't let me. Oh, there we go. Copy. We're going to a translator. Hang on, function number 1. Sorry, we're learning some. Wait, nope, I don't need that. Okay, this is getting annoying. TRAN. Jeez, man. All right, cool. We're detecting the language. We're going to print that language. The language detected. Sorry, Samir. I can't translate it. It won't work. What I am doing, I am working on some half-inch flex. We're doing half-inch hardline. We're doing a 7/8 EIA to it. I was trying to translate. I believe it was some Saudi, but I cannot translate because my translator doesn't work. It won't take the words. Let's put this O-ring on real quick. Get that all prepped and ready. All right. Now let's take our body of this, slide her down, get our spring retention clip. Pretty much is what it is. It's just when we build our flange, it gives us something to build off of. So it's pretty neat. I think 144 megahertz or so, around what we call the 2-meter band, is actually pretty popular over in the Persian Gulf. So it's pretty interesting to know. A lot of operators over here would probably already know that, but for the general public that doesn't know what other countries like to transmit on. So we're building our flange right here on the inside. See how it's flaring out? I need to flare that connection out. Yeah, the QR code that you need to scan is that one right there. It's the website, DWin's RF Supply. I actually made that. I don't know how many people are actually going to use the code and versus just typing in dwinsrfsupply.com. But hey, I put it on there, so whatever. Let's do a plunge test real quick and measure here. So we're going to measure our center conductor length. It's going to be too long. Let's go ahead and push this dielectric out of our way. So when you're working with connections like this, the dielectric it needs to be there because it does provide basically isolation between conductors, and it does a good job. But you cannot have it getting in the way of your termination. If it does, then you unfortunately do not have a good termination. So I need to cut 3 millimeters off of this. So I'll measure this down to 3 mil, which is right here. And we will mark it at 3 mil right here. And we'll chop it at 3 mil right here. So, got a big chunk of coax. Yes, sir. Some good stuff. All right. I will translate for you. He said hello to some friend in the chat. Oh, okay, cool. Hello, Samir. Ciao, Zane. I'm not sure. I don't know if you're just joking around. Hey, man, I got guys from all over. I don't care where you're from. I'll say hello to you. If I can translate it, I'll say hello. But I do not have a wide vocabulary when it comes to other languages. I have very basic words in. I guess I have a few basic words in Hawaiian. I have a few basic words in Japanese. A decent amount of words, nothing crazy, in Spanish. And that's it. That's the limit of my knowledge. All right. So, let's get to work. Now, scary part. When you go to put these connectors on, the goal is to try to pull it off. If you can pull it off, you didn't put it on to start with the correct way. So here you're going to grab it. Try to pull it off. If you can't pull it off, you did a good job. So that is the end of that one right there. So now from here, what I've got to do is I've got to build a couple brackets and a couple other things, but I'm not going to be able to do that right now. Copy, it's Persian, it's hard to translate. Person, turquoise, wavy. Well, that's very cool. Thank you, Jackie. I do appreciate the assistance there. That's great. So we have, oh Lord, EIA number 1 with split feed. EIA number 2 without split feed. EIA number 3 right here. I've got more to do to this harness, but I can't do it today, so I'm going to grab something else and do a couple more pieces real quick. I will finish this harness very soon. I should probably be finished. I don't know if I can finish it this week, but I will do my best to try to finish it this week. But they've got several other things on their order, and I'm going to look at their ticket real quick. Ouch, that is my foot, and that is a piece of metal. Get out of there. Booger poked me in the foot. All right, so we're going to grab our device right here and see what's on this order. I like to check my tickets to make sure I'm getting everything correct. Well, let's get it pulled up. All right, we need cable, split feed, standoff, clamp, clamp, QC. I need an adapter, another adapter, and slug. Okay, so I can't finish that one up. I've got a little bit more to do. I will get that one finished up. Hopefully tomorrow. If I'm not really doing anything tomorrow, but I'm gonna try. I don't know if I can or not. I'll try. I don't do work on Fridays, but I might try to do a Friday job just to try to help out with that one. So I've got these bird meters we're going to be working on very soon. But for now, I'm just going to knock out some of these RG400 jumpers for now. I've got a little bit more work to do on the other one, but like I said, that'll be tomorrow. I got to move that whole harness around. I've got to tie all the stuff back together and then finish it back up. So it's a lot of fumbling, a lot of moving, and a lot of very annoying, tedious stuff. And it's not something that I will keep a lot of viewers watching the stuff. So that other cable is from me, from D-Win's RF Supply, right here. So D-Win's RF Supply. It is, I don't know if that shows up on TikTok or not. I don't know. That's the one who's asking me. Yeah, it showed up fine. Whatever. That's not super focused, but whatever. It's good enough. But dwinsrfsupply.com. That's what he ordered it from me. Like to make small subwoofer. Can you please give me some advice? I'm a circuit designer. So you have to make a voice coil. So a voice coil has a certain impedance. I do not make subwoofers, but I know enough about audio circuits to kind of get you by. You'd have to figure out what impedance you're trying to go for. So whenever you're doing that, you have a magnet, and you have a winding that goes around that, or electromagnet is what you have. A lot of times they'll use a permanent magnet. This is a coaxial cable, and so was that big cable you just saw a while ago. The bigger cable you saw a while ago is going to be right over here. This is 1/2-inch hardline versus RG400. They're both coaxial cable. They both transfer signal from point A to point B, but one handles more power and has far less attenuation. Another one has a lot better friction coefficient, so it's easier to slide through connections and stuff, and a lot higher thermal capacity of handling a lot higher temperatures. So they're all made for their own purposes. It just depends on what you need and what you're doing. I will suggest a coax to you based off of your request and whatever application you want to use it in, and then I will give you suggestions. Yeah, so you'll need basically a permanent magnet to the permanent magnet. Then you'll need a bunch of what's called enamel-coated wire, and then you'll have to wind that enamel-coated wire. And then you're going for a specific impedance. Impedance is a frequency-based resistance. So it's going to take some test equipment to be able to do that. You need to research what test equipment you need to get to be able to measure impedance at your frequency that you're looking for. Most likely, an LCR will do what you need it to do. You wind that, get the impedance you want around that magnet, and then what you're going to do is energize that magnet with basically voltage. So you have to have an amplifier to be able to do that. So you have a specific voltage that you want to drive into it because you want the coil to move at certain frequencies. So that is your basic concept of how to make a subwoofer. I'm not going to tell you the whole concept because I do not have the design specifications on my person at the moment, and it is outside of what I do. I am D-Win's RF Supply. That is the company name. That's my business. I do RF circuits. So when it comes to DC circuits or audio circuits, they're not. It's not my field. I know enough about it to tell you what to do, but I do not know enough about it to sit there and build you a circuit. So that is your piece of advice that I can help you out with. Hopefully it helped. So this it's for Coax is used for CB. Coax is used for ham. It's used for ham or amateur radio, whatever you want to call it. I've sold some of this coax specifically to an airport. Coax can also be, it can be, this is used specifically for aviation and aeronautics is what it's used for a lot. But it can be used absolutely for CB. It could be used for any sort of repeaters. It could be used for all kinds of stuff. It's a really good cable and really versatile. It's very good for jumpers, for anything. So the answer is yes, it can be used for CB stuff if you was going to build it that way. Let's go grab my pick. It is over hiding somewhere from me. So it's literally right here. Do I own the coat? So, Donnie Paul, to answer your question. For the guys that don't know, that use words before, let's say that. For the guys that don't know, yes, I own coax prep tools. The entire purpose of this page is not to, excuse me, I didn't even put them in the right shot. You guys couldn't see them. So yes, I own coax prep tools. I can prep with any coax prep tool. I own many more. There's lots of other things that I have. But the entire purpose of this page for the guys that are new here, it is to teach you guys how to build coax with just regular tools that you can get at the hardware store, that you can get somewhere down the road. Been doing this for a lot of years. I could do this in my sleep, but I do this on video for you guys so you guys can learn how to make it. And not everybody has $300 per end that they want to put on to prep the tool or to prep their equipment. So this is why I do what I do. I'm going to turn this camera just a little bit so you guys can see a little better. And I think I'm going to turn this camera too. Yeah, that's pretty good. That should be a pretty good shot for you guys on YouTube land. What's up, Rodney? Waving a hand. Thank you for the follow. I appreciate you, man. But yeah, no, you will not see me using the coax prep tools. You won't see me spending using a $150 tool to do cut a jacket, or using a $3,000 full stripper that's used for multiple sizes. Even though I own some of those tools, I don't own the big $3,000 stripper because it's not something I need for what I do. I don't like how it strips, actually, to be honest. That's for guys who don't know how to actually do it themselves. But yes, coax prep tools are just a guide to get you somewhere you need to go. So if they have a coax prep tool, what it'll do is it'll cut back, say, 27 mil, and it'll cut back 7 mil or something like that. So it'll cut your jacket and it'll cut your center conductor for you, but you still have to do prepping for your flange and other things like that too. So even if you did have the tool, great, all power to you. But it is an overwhelmingly safe tool the way it's designed. And in my opinion, even if I did have it, I don't like using it because it does not build enough of a flange for what I do. I like to overbuild rather than just build just good enough. Now it works, and it will work just fine for broadcast or telecom or anything of the sort. So don't get me wrong, it will work just fine, but it just won't handle quite as much abuse. But yeah, I use rudimentary tools, stuff you can get at Home Depot and stuff you can get at the auto parts store or your local hardware store, because the goal is for you to be able to use the stuff you already own or the stuff that you can easily access to put on a $12 connector or put on a $30 connector, not spend $300 just to put a end on. So I think one of my connectors is 381 and the other one is 286 or something like that. just for one particular size connector to put one particular type of coax on. So that would defeat the purpose of this page. Let's just say it that way. I would not be making these videos if I'm sitting there showing you that stuff. The goal of this is for you guys to learn. Hey, no problem, Jackie. I appreciate you asking. Thanks for the interest. Sorry, Donnie, I wasn't trying to pick on you or nothing. So don't feel like I'm angry or upset with you or anything like that. I'm just trying to explain that that is not the purpose of this page. I am not going to sit here and make you guys watch me use a tool to put a coax together that you couldn't, not necessarily couldn't possibly, but there's no reasonable reason for you to be able to afford that connector or that, excuse me, that prep tool. So what we got here is we're going to go ahead and solder this up real quick, and I'll show you guys how to do that. So what I typically will use is a soldering iron. You could use other things, but soldering iron is definitely going to be one of those things you probably want to invest in. You can get a decent Weller soldering iron for around $100, or you can buy a battery-powered Ryobi or Milwaukee for around the same $100. The reason I say battery-powered Ryobi or Milwaukee is because I've used the Ryobi and I assume the Milwaukee's just as good, and they work just fine. So it's not like you're gonna stop working altogether if you don't know how to don't have a $400 or what is this thing, $600 soldering iron like I got. It might be a bit cheaper now because it's used, but still, it's if you don't have one of those, don't fret. You don't have to have. You need about 600-700 degrees to work with, and you need about $100 iron or so. So I've even made it work with, what is that tool? How much does it cost? Weller makes a butane torch for about $45 or something like that, $45 or $55, something like that. And that thing works exceptionally well. You just got to be careful to keep your finger away from the open butane hole because it will burn you because it has an exhaust port. But other than that, if you're safe, it does a good job. So the key here is to hold the actual iron on the source you're actually trying to solder to, not touch. You want to keep contact on it for a significant portion of time. The goal is to preheat and get it to temperature, and then you're adding your solder to the source, not to the iron itself. If anybody's ever dealt with TIG welding, you'll hear that said a lot. Add your fill to the actual puddle, not to the touching the tungsten rod. Now, if there's nothing else to do and it's too small of a hole, sure, you can touch the soldering iron because you have to have it wick in there somehow. And that's what I'm about to have to do in just a moment. Can you see? I'm zoomed in pretty decent. I could zoom in some more. Hey, thanks for the like. Appreciate you liking the live. Bubble, appreciate you. Thanks. So we're working on, like I said, some RG400. I'm doing some UHF connectors. These are PL259s, if guys are not familiar. So what we have to do here is, because this is a double braided wire, and it's a silver plated copper, and it also has a silver plated copper center conductor, and we have a decent body of metal here. We need to heat it up pretty quickly. It will wick. It's got such good heat conductivity, it'll steal all the heat that I've got built up on this connection in a matter of a few seconds. So what I have to do is I have to get it up to temperature and then keep heat on it in order for it to do what I need it to do, in order to bond, for it to wick into these joints. So what I'm doing is pulling solder into that hole, Moving on to the next hole, add heat to the joint, put the solder in the hole, not as little on the iron as possible. If it hits the iron, so be it. It just is what it is. But the goal is to get it into, fill the pocket of the hole. And then heat up the iron, or excuse me, heat up the hole so that it wicks properly. Well, it's good. I just messed it up. Not bad though, cleaned it up there. Rotate to the next hole. Now I have to get in a weird position right here. So I'm kind of forcing that tip down to a workable position. And go ahead and get on the next joint right here. You got to be careful not to lose too much heat. Keep the iron on it for as long as possible. Within reason, you got to maintain temperature. You want to see how the solder pulls into the hole on how much heat you should keep on it. All right, now that is currently complete. We're going to go ahead and go to the next coaxial. So I'm going to try to get it to focus real quick. Give me just a moment on TikTok. I got to click the image, and you can see. Trying to keep it nice and focused, but it ain't. It's kind of hard. I got to almost put my hand in the way. I can't burn myself, though. I got to be careful. But you can see how the holes are nice and covered. You want to make sure that you're not letting anything wick up. And you want to look at the center conductor right there. It's nice and bonded all the way around. Now, Facebook land. See if this works. See if I can get this thing to focus for you guys. It wants to focus on my hand behind. So I'm probably not able to focus on this thing. I can't do it. Whatever, I'm sorry. Facebook land, I can't focus for you guys. You guys will just have to trust that it's soldered properly. Facebook and YouTube, that is. But you guys can see pretty decent from that there. All right, let's get the focus fixed on that. That's already fixed. We're good to go. Do I work on CB or do I just do coax? I am an RF supply company, so I supply RF components to people. So I supply RF components to amateurs. I supply RF components to CB guys. I supply RF components to big companies. Doesn't matter who they are, I supply components to them. So as far as me working on individual devices, unless it's a bird meter or assemblies and things like that, no, I do not work on radios. But yeah, I am a supply company. I'll supply parts to you. I'll supply you, get you a fancy little transistor there. Or bird equipment, slugs, and all that good stuff. I got a bunch of that stuff. So, I even got some tubes over here. I got a bunch of tubes, actually. Nice. I did it for a phone, so nice. I did that for a couple. Did a couple for a friend the other day. I need to vary some of this coax for my mobile at some point. So I typically stock 218, and how much more power can it handle than RG217? RG217 is good for about, I don't know, 5,000 or 6,000 average. You might be able to squeeze a little bit more out of it, but mainly 5,000 or 6,000 average. RG217 can handle probably about, what is that? Probably about 13,000, 14,000 average. So RG218 would handle significantly more power. You're talking about more than double. So, if you was to compare sizes of coax, I've got a little size comparison chart for you right here. We'll put some RG400 right here on the bench. You guys can see what it looks like right there. I've got it on the end. We've got some RG393. No, excuse me, some 1 5/8. That is some 7/8 right there. There is some RG218 right there. That's what 218 looks like. There is some 1/2" hardline right there. Do I have any 1/2" flex? I have some 1/2" flex. Let me just grab some since I can show you guys. We'll do a whole comparison real quick. We got a short piece somewhere, not so freaking long. There we go. There is some 1/2" flex right there for you. Here is some like LMR 400 kind of style cable right there, and that is RG393. And then of course on the end would be RG400. And in between there would be like your RG8X and stuff like that. So you can kind of see how the power handling goes up. RG217 is around the size of these two cables right here. It's in between the two of those. RG218's here. 7/8 hardline is here. And 1 5/8 hardline is there. Look at that junk out my throat. Oh, I forgot. I didn't show you how it goes the other one. I got a fancy one. Where's it at? This stuff is expensive. This is the 1/2" Teflon cable right here. So I got some 1/2" Teflon cable too. All right, so let's get back to work on this. So I've got all the parts prepped for that one. So let me just grab some more parts. Can I fix a JBL 500 0.1 Crown car amplifier? No, sir, I cannot. I do have some other guys that I deal with that may be able to fix stuff like that, but I do not currently work on anything car audio, nor do I get down into component level work. I am capable, I just do not, because I am an RF supply company. So I have a lot more parts that I'm building. So right now I'm currently building, you guys can't really see them in the show. Actually, you can on TikTok. I'm building these bird meters right here. I am building some 1/2" hardline I just showed you guys earlier, some RG400 here. I'm building some 1/2" flex, some more 1/2" flex. I'm building some coax standoff mounts and all kinds of other stuff. So I am kind of loaded up on what I do, and I have not expanded into anything like that. And I got another bird meter I got to do too on top of that, and then another 2 bird meters I got to ship. So RF related. I don't get into the audio world, even though I could. I just don't. It's just a little bit too much. There's only so much work that one person can get into. So I stay in the RF world. But I do component level soldering. I'll solder down to 0.0201 packages. So you're talking about 8. If you was to measure the size, I wish I could show you, but it is 0.8 millimeters across. That's 402 package, and 201. I forgot how small it is. I think 201 is 0.8 millimeter, and 0.0402 is 1 millimeter across. I can't remember. I'd have to look up the specs again. CB coax. It can be, yes. You could use it for CB. RG400 was smaller than I thought. I had to get new, smaller reducers. I know, right? Don't you love it? I think it's a good start. Cool. Like I said, you guys got questions anywhere, you guys feel free to ask me anything you like. I will try to answer it the best I can. But yes, Country Pimp, it can be CB coax. It could be CB coax, VHF coax, UHF coax. It can be used for anything in HF spectrum. It kind of starts getting super lossy, anything above about, I don't know, 200 meg or so. So yes, CB being 27 megahertz, it will absolutely do 27 megahertz with no problems and work extremely well. I built a ton of wire for CB, guys. Alright, so I need my little cutter. I need my material over here. What am I doing? I ran out of my little, this has a built-in igniter, but the igniter failed. I've been using it, I guess you would say, in a close to commercial aspect, and it's more of a like a personal, like hobbyist kind of use. So the little piezoelectric igniter finally failed on me. I tried to fix it. I fixed it once or twice, but then it finally just died on its own. It still sparks. It just don't light it up. Maybe I can figure out how to work on torches and get her back going again. Alright, so we're working on some RG400 coax right now. Is what we're currently working on right now. I'm doing some UHF connectors on it. I've got to get several cables done. We're going down to Gulfport, Mississippi next weekend, and I'm going to try to get a couple orders ready. I've also got another order. The first order I was working on was going to Hawaii, so I got to ship it out. It's a larger cable. This one is going to Louisiana, and there's another cable that's going technically to Louisiana, but it's going like oh man, I didn't pass my puzzle on TikTok.
Are you scrolling instead of sleeping?
That sucks. There's a puzzle on TikTok that you have to pass, and if you don't pass the stupid puzzle, it kills your whole life. And me, like a dummy, I was too busy talking and wasn't watching, and it killed my own daggum life. So, that's annoying. It's alright, though. Not the end of the world. All I gotta do is click live again, and I'll go back live and see who else hops in here. So, I've got to build the wire anyway, so. View profile, let's go back to my live. Click the. Well, what's up, Jerry? My live got killed while I was in the middle of working because unfortunately I didn't pass the puzzle. If you guys are hopping back in here from the previous live, the way I'm working, I'm way over here and you guys are all the way over there, and I'm not able to hop up and look at that. So I pop a different screen on so I can see what you guys are doing, what you guys are saying, and it keeps biting me in the butt. There's a puzzle I've got to pass, and I need a little monitor. So what I'm going to do is Small Rig. It's a company for camera accessories, but they also got a little screen about this big. It's a little monitor, and it's battery powered. And what you can do is screen mirror. So I can screen mirror right here, what's on that phone right there. And it'll show me when my puzzle pops up. And I got 5 minutes when the puzzle shows up to pass the puzzle before it kills my live. So that was absolutely unfortunate. I lost all my other fellas. We had some guys hopping in here watching and seeing what we were doing, and was asking me questions. But if anybody goes live in the future, if you guys wanted to know, there's a puzzle you have to pass about an hour in the live. If you do not pass that puzzle, it will kill your live. I think it was because a couple years back, there was a bunch of guys out there that was doing videos while they were sleeping, and they were making money on their lives while they were sleeping. So TikTok decided that it didn't like that, and you have to prove that you're actually there and it's not a fake video or stealing somebody else's video or anything else like that. I guess. I hope so, at least. All right. So we're working on some RG400 right here. If you guys don't know what RG400 is, it's a type of coaxial cable. This coax is this right here is usually used in aeronautics and aviation. So you will see it. It can be used in very, very high temperature applications. So it's used in aircraft a lot. It's also got a very low friction coefficient, so it's super, super slippery. Let me zoom in this camera real quick so you guys can see what's going on a little bit better. Zoom, zoom, zoom. Up you guys over just a smidge. kill this thing right here so this thing's not blocking my screen. How do I get off that? Should be good. So you guys can watch what we're building. So, hello Chris, hello Tom, hello Karen. Hope you guys are doing good. Hello Texas. Brian Smith. I've seen it pop up right there. I don't know what that was. I know a Brian Smith. All right, but hello guys. Hope you guys are doing well. Jeff, Special, Tall in the Saddle. Appreciate you, man. Hope you guys are having a good evening here. I'm currently working on, like I said, some RG400 coax cable. If you guys want to know what it is, ask, and I'll tell you all about it. What's up, James? What's up, Joe? How you doing? Sorry, I'm too busy watching the screen. Brandon? Oh, RG400. Somewhere a little bit above 12 foot or so, David. What's up, Key? What's up, Chris? Hope you guys are doing well. We are Edgar, Megan. Hope you guys are having a good day. We're working on some RG400 cable today. This is a coaxial cable. If you have a cell phone, if you've ever heard the FM radio, this stuff right here is used on stuff like that. Actually, if you've ever been in an airplane, most likely this stuff right here is used. So it is commonly used. This stuff is more in aviation. I've got some bigger stuff. This is your 1 5/8. That's usually on your cell phone towers and stuff like that. It has started to change here recently, and they've run the fiber all the way up to towers. This used in like your MRI machines and things like that right here. This right here is commonly used on your cell phone towers and stuff like that, along with this somewhat, and then this right here even more for a lot of your smaller terminations and things like that. So that is some of the stuff that is used for different frequencies and things like that. I've got a lot of different coaxes that I build, but we're currently building on some RG400. I made a mistake, let this thing get a little cooler, so I might have to reheat this thing back up, but I think it's worth showing you guys. If you guys don't know how to solder, the goal on soldering is getting it to wick like you would a, if you're trying to get something to wick, you would do it like a candle wick. So if you've ever watched a candle wick, as it you dip it in the oil or anything like that, like an old oil candle, you'll watch the whole wick will get, it will wick into the wick. So you'll actually watch it suck into it. So I'll give you guys a real world concept of that real quick in just a moment. Let me grab a rag and let you guys see how this works. So when solder gets hot, it turns into a liquid. So if you drop some water right here near a source, right? And then we put this rag near it. See what happens? It wicks into the actual, the cloth material right here. Same thing we're doing with solder. We're wicking it into that joint. We just have to give it hot enough in order to make it liquid and to keep it liquid in order to suck into that joint. Now, it doesn't work as well when I'm not up to temperature, and what I have to do whenever I'm not at the proper temperature is I just do a quick heat of it. So I use a torch right here. My little igniter's dead on it, so I gotta light it up. So I'm heating it up until I watch that solder wick into that joint. So it just sucked into the joint. I don't want to heat up the whole thing too much. I just want to heat up that local area right there a bit, because I don't want all the solder wicking to the very bottom. I want it to wick to each one of these holes. And I want to bond the shield that's in the wire to the actual cable itself. So you guys got questions, you feel free to ask me. It does not hurt my feelings to tell you guys about this stuff. Like I said, we're working on some coax right here. This is something you won't see every day. You'll see it basically in the airplanes and stuff, but you won't see it actually getting worked on too much. This right here is being retrofitted for a different individual because we're putting a different type of connection on it. This is called a UHF connector, or a PL259. It's used pretty commonly in your amateur and your CB radio stuff, anything to do with your like hobbyist equipment and stuff. What you'll see used a lot of times in aircraft and broadcast and stuff like that is an in connector right here. You'll also see the female version right here. This is a 7/16 DIN right here is what this is. I think you guys are in the right shot. I don't know. I don't know if I showed you guys the in or not because I didn't look at the camera angle, but that's an in connector right there. And then also you can get into the military stuff and they'll use this connector right here. This is called an LC connector. So let's get back to work. I'm going to go ahead and get another end prepped real quick. So we got 2 of these things already ready, and we're going to go on and move on to the next one. So if you guys have questions about them, like I said, feel free to ask. It doesn't hurt my feelings at all to tell you about this stuff. So the braid is just laying in there and the solder wicks in. Yes, if you watch me real quick, I'm about to start over on another one, and you'll see how it goes in. So I have a ring, then I have a reducer, and then I have a center contact. So let me make sure we're at the right angle. I think I should turn you guys a little bit to the right so you guys can see just a smidge better. I think it'll be better. I don't know. You guys let me know. That's a little too much. I think it's too... Sorry. This gimbal is freaking fast. Drop the camera down, turn it over just a smidge right there. That should be good. So, ring right here, reducer here, and then this is your center body of the connector right here. So the reason we have a reducer is because we're using a connector that's designed for multiple types of cables. 73 FL, F4L, FG, hello. Dot, thanks for the follow, appreciate you. Chris, we will continue with Chris's question real quick. Thanks, LMR 400 in the past has been around 15.6. I got you. All right, so what we're gonna do is we're gonna measure. I can use a caliper and show you guys the fancy way. Let's do it, I don't care. So, I'm gonna take a little bit more time and explain how this works. We want this center conductor, the inside piece, to go all the way up in here. And we want the shield to go here. So what we're going to do is measure and figure out how far or how deep this connection is. So we'll do a little plunge test on the caliper right here and make sure it goes all the way to the bottom. So this measures 25 millimeters, but I can just cheat. I can just use this as a guide, right? So I lay it out right there, and if you look, it's right at the base of this little crimp connection right here. So what I'm doing, I gotta stay in the shot. I apologize for TikTok guys. So what I'm doing is lining it up right there. So this is my measurement. I usually do it by eyeball because I've done it so many times. But you could measure it exactly and get the inverse of whatever that other length is, and I can give you the exact millimeters that you needed to cut this at. But you guys are lazy and don't stick around as much, so I am just working on it real quick. So this is a double braided shield, so what I'm going to have to do is pick at it right here with the pick in order to get this braid split apart. If anybody who does hair that's ever dealt with braids absolutely will know what I'm talking about. Guys like me generally don't know anything about this because I don't really braid my hair. And like best I'll get out of my daughter is like a French braid or something like that. They don't do like super tight braids. So anybody who deals with braids would be like, yeah, duh, you need to use a pick. Well, you are smarter than me, or at least in the past were. So now we're going to go, because I actually did it by hand for a while there. So next, we'll take insulator right here, put that on, line it up right here. So we have center conductor, shield. These are two separated pieces of equipment right here. Oh, wait. So this further separates those connections right here. Then I take this body right here. I got to make sure I've got some connection exposed so I can solder to it. If it's not exposed, I can't solder to it. So then I just make sure I don't damage the center. Poke the center up through the hole, and the body, that wire that we folded over on the outside, is right here. So then we take this reducer that's right here. Oh, you can see I actually exposed some of it on accident because I pushed up on it. So I pull that back down right here, and then I take this reducer and I force it up in that hole. And what it does is it grabs all that braid that's up in that connection right here and jams it up into these threads. So technically, from an actual perspective, this connector is done after that. What I do is go a little bit overkill, and I go ahead and solder to that body. So I bond that body to the body of the PL259 or the UHF connector to the shield. So we're nice and tight. So technically it holds on and does a good job just the way it is. It has no problems and will work just fine. But I like to seal it up some more and work on it a little bit better. I had a little bitty strand coming out of the hole, so I went ahead and cleaned it up because that just irritates me. We'll throw my zip tie away so I don't have to deal with that no more. Thank you, Ronnie. Appreciate you. Sounds painful. Well, it's not too bad. I've done it for a lot of years. You could burn the crap out of yourself touching this soldering iron, though. I'll tell you that much. Georgios, thanks for the follow. Ronnie, thanks for the follow. Appreciate you guys. So I have a little bit of the center conductor that's poking above the top, so I need to go ahead and take that and cut it back so this can be a nice and clean connection with a good termination on the end. It matters for impedance match, stuff like that. So that's what we're doing here. So this is insulated. It looks like a solid piece of metal and I'm about to burn my fingers, but there's a big insulator right here that separates me from that hot connection on the very end. So what you're doing is you're adding heat to the source and you're adding solder to the source. You're not actually adding heat to the iron, or adding solder to the iron itself. Your fill material needs to go to your heated connection, not to the actual iron itself. It can work with the iron, but you'll have a lot better joints when you actually go to the actual source itself. Because if otherwise you're trying to get it to wick off the end of the iron into the source and come out with a clean connection in the end. And that's kind of hard, to be honest. So next, we're going to go ahead and go to the body real quick. I'll show you guys how this works. So whenever I'm heating this up, it gets nice and hot, right? So I've got a lot of heat. But the problem is this entire wire is nothing but copper. So it's actually silver-plated copper is what it is. So it's a double braided jacket, a double braided shield. So we have two braids on the outside, and we have a braid on this the center conductor. So copper is one of the best, just below gold, heat conductors. So it'll actually it transfers heat extremely well, or excuse me, absorbs heat extremely well. So what I have to do is have to heat this connection really, really quickly so that it doesn't steal all my heat from the end of this connection and transfer it down the edge of the wire. So I think we're still in the shot no matter what I do. That should be good. I got to be careful when I zoom in like this, and because you guys can't see sometimes. So watch it wick in. See, it just sucked into that joint and just disappeared. So as it wicks in, that means the joint is now hot enough. And what I do is I hold the solder to the actual connection point, and then I add, the iron to the piece I'm trying to heat, and I add the solder to the piece I'm trying to heat. As soon as it gets hot enough, it will bond and start wicking into that joint. So I got to make sure I've got good temperature and also got good connection. So whenever I'm connected as flat as possible on this connection, I'm trying to make sure it stays nice and hot because I want it to continue to wick into that joint without burning my fingers. Now, you see how close my fingers are? I'm already feeling heat in that connection now, and I've got 3 more holes to fill. So I've got to make sure I maintain and watch out for how much temperature I have on this joint because, like I said, it's robbing from the heat. It's robbing from my connection here. Luckily, this wire is super, super forgiving because it has a very high thermal resistance, pretty much. It can handle up to about 500 degrees with no problems. You cannot do this with other coaxes, only with your fluoropolymer wires. This has got a fluorinated ethylene propylene jacket and a polytetrafluoroethylene center conductor, or excuse me, dielectric. The dielectric is Teflon. So if you guys don't know what PTFE is, that's what that is. That is the chemical code for what Teflon is. So it is used for very specific applications. It's good for a very low friction coefficient. It's used for a high dielectric strength and a few other goodies here. Now, luckily for us, we're not eating this, so we don't have to deal with the controversy that other guys would say about putting it in your pots and pans. So we're not putting this in our body. We're not heating it to the point where it's above its melting temperature, like what happens when you fry it in a frying pan. So in this instance, it is very good and very, very useful. It has a lot of good thermal and electrical properties that we need it to have. So that center conductor is done. I'll show you guys on TikTok since I was able to last time. I cannot get Facebook to focus, so I apologize to you guys. But you can see how she bonds all the way around. So you want it to wick in nice and smooth on those joints. It doesn't have to be perfect. It can bubble out and stuff, but you just want it to be sucked into those joints. And that center conductor right there, you want it to be bonded all the way around and connected. You don't want to see gigantic holes and things like that. If it had a big old hole in it, that would mean you have an inclusion and you have a chance for that wire to to fail in the future, especially if you get weather inside that connection. All right, this one is prepped. Let's go ahead and do another one. I've got several to do, so let's let you guys see it one more time. What's up, Daniel? What's up, Phil? What's up, Chris? Hope you guys are having a good day. Thanks for sharing the live drill. Thanks for following Georgios. Thanks for following Falco. Appreciate you guys. I hope you guys are having a good day. If you guys are liking the video, feel free to tap the screen if you like it. I do appreciate you guys. You guys are great. Apparently TikTok has a little bit more weight on whether or not you tap the screen and like the video on rather than Facebook and stuff. Facebook and YouTube, you can like it once and you're good. But TikTok, they want you to keep tapping the screen for the video to be considered good, or whatever you want to have, quotations wise. All right, so like I said, we can talk a little bit more about what this wire is and what it does if you guys got questions, rather than me explaining how to do it again if you want. So whatever questions you guys put in there, I will answer. Otherwise, we'll continue talking about how to build these. I didn't prep and see, look, I messed up my prep. I need to put my reducer and my ring on before I can do this. Like I said, questions are appreciated, guys. If you guys want to know what this coax and stuff is, this is commonly used in aviation and aeronautics. So a lot of times, if you've ever been in an airplane, this wire has probably been in use before in the plane that you were in. So that's a pretty neat thing to be able to tell people. What's the 20 on poly? So what it is it's polytetrafluoroethylene. I believe it's correct. It's PTFE. Definitely sounds like a space name, don't it? FEP is fluorinated ethylene propylene, and that is the exterior jacket. That's what this stuff is. So, like I said, you guys got questions, you guys want to know stuff, I don't mind explaining it. We'll talk about this stuff from a technical perspective, or we'll break it down to where it's simple. I am completely open to telling you guys how this stuff is, what this stuff is and what it does. For the guys that don't know, if you have a cell phone, if you have ever been in an airplane, if you have ever listened to your AM/FM radio, you have dealt with this or something very similar to it before. This is called coax. Also, if you have Wi-Fi at your house, they have this stuff right here. It's inside of your router. So not specifically this, it's actually a bit smaller. They use rigid line a lot of times, and sometimes they'll build it into the traces, but it's still coax. So, this is for connection to an antenna. So this is what's called feed line. It transfers signal from point A to point B, and the goal is to try to make sure it doesn't, in most applications, to try to make sure it doesn't transform the impedance. make sure it is faithful to reproduce what is on one end to the other end. Sometimes you'll try to get it to modify stuff and you'll use it like a stub tuner and things like that, but that is limited in scope and application. For the majority, you're just trying to transfer signal from one side to the other. All right, so yeah, so we're working on this. We gotta go ahead and push this all the way up inside this connection, get it nice and tight. If you guys are questioning, curious, or just don't know what the heck I'm doing, feel free to ask. Like I said, I do these videos for you guys to learn and see what I'm doing. So they are not, it's not a shut up and watch video. So interact, ask questions, tap the screen if you like it, share the live if you want to show somebody something cool. Maybe it's cool to you guys. I hope you guys like it. Those RCA cables, they are similar. RCA cable has usually a twisted pair a lot of times, and sometimes they'll have it set up in a coaxial configuration. But this stuff is coax, so it transfers RF signal. RCA cable will transfer audio signal. So the limit of RCA cables is usually about 20,000 hertz, maybe 50,000 hertz or something like this. This right here can go up to 1 billion hertz. So, and what it can transfer. So that gives you a general idea. It's not typically used in 1 billion. It's usually used maximum about 400 or so megahertz is what it's usually used at the top end of the scale. Sometimes in limited scope inside units and stuff, it'll be used up to 1 gigahertz, but not super often. Thanks for the share on the live. Appreciate you. Thanks, Jamie. Can I eat that kind of wire? No, that would hurt you. It would not be smart. We did some dumb stuff as a kid. I think we were at what the heck was it? A little buffet thing. And I don't know where the heck boys get up with this stupid crap, but we had a bet or whatever. Jets, I use mil-spec wire similar. This is mil-C-17G. Yes, this is mil-spec capable wire. It is definitely used in aerospace for sure. KC-135 Stratotanker. That's very cool. Nice to know. So this has got a very high, very low friction coefficient, so it can fit through and flex and move with the aircraft and the airframe and stuff without damaging the wire. And then also it has a very high temperature rating, so it can handle up to about 500 degrees. So, and also very low in temperature too. So when you get into the sub, 90 degrees below zero on Fahrenheit, a lot of times other cables would fail, where this cable will work just fine. It won't hurt the cable at all. So it's got a very, very good temperature range that it's capable of handling. Like I said, more questions is perfectly fine. I got a fella talking about some aircraft over here on Facebook land for you guys on TikTok. So it is definitely cool. Now they won't use these UHF connectors because the UHF connector is technically a 52 ohm piece of connector. A lot of times they'll use your N-type connectors. They'll use your, let me see if I can get one of these apart over here. Let's just pull this one apart right here. Your SMA connectors like this. See if you guys can see it. SMA like that one, or your BNC in some applications. A lot of times it'll be SMA because they don't have a lot of power handling. They just need the capabilities of the cable, not really the power handling of the cable. So let's get back to work. Keep soldering. Sorry, I will read you guys' comments in just a few seconds. We have to add a lot of heat to this, and I decided to be a little bit bold and remove heat. Generally, this stuff has such a very, very good thermal conductivity, that what happens is it'll actually literally suck the heat away from the center conductor, or the body of this connector, into the wire itself, and I have to add some heat like this if I don't have enough heat on it to start with, like if I let it cool off enough. If I was home, I could give you the part number. That'd be pretty cool. RG178, RG179, RG303, RG400, RG316, RG393. All that stuff is the type of cable that I will deal with. Mustafa, thanks for the follow. Appreciate you. Velocity factor on this is 69.5%. Any Teflon-based coax is going to be 69.5%. Can you explain how to properly solder? It drips off for me. So what I did, you saw me heat up this joint. I got it nice and hot. So we got it probably 300 degrees right now. You cannot do this with other coax. Don't copy that. But once it's hot, what I do is I add solder to the actual joint, the connection, not to the actual soldering iron. And I keep the solder there to get it nice and warm. So if you'll wait just a moment, I'll show you how to do the center conductor, and that is true for any soldered connection. Doesn't matter what it is, if you're soldering something. Actually, I'll do you one better. If you'll hang out for just a minute, I will show you how to solder wires together. So we'll grab two wires real quick, and I'll show you how to solder them together, so you can understand the concept and what we're doing, so you can picture it just a little bit better than me doing all these connectors and stuff. So I don't mind spending a little bit of time showing you guys. I think it's a good little representation for you guys anyway. Stay up there just for a second longer, buddy. It's got such a low friction coefficient, so what I'm trying to do, I typically can hold it right here with my fingers, but it's so slippery that it just slides right off. So I had to have it rested against my hand in order for that to connect. So nice and cleaned up right there. Good to go. Another one finished and ready to go. Not ready to go, but it's partially finished. So let me grab two wires real quick. I'm just going to grab just some regular Dorman cable. You can get this from your auto parts store. So we're just going to cut this end right here. I can use a pair of dikes and strip it, but I'm just going to cheat and use the strippers just because I've got it right here. And most of you guys will want to use the stripper anyway, because dikes, you'll have to clip it twice. So pull it back to itself right here, right? So we need, first things first, you want to solder to it, right? So what am I going to do? The first thought for most people is, okay, I need to connect them together. No, that is not the first thing you want to do. I'm out of Georgia, Unique. So if you guys wanted to order anything from me, it's dwinsrfsupply.com. That is my website. Also, you can message me on here and I can talk to you guys about whatever you'd like to order. If it's RF, that's what I do. But I don't mind showing people how to solder too. So you do not want to try to solder them together. That's not the goal. Not yet, at least. What we want to do first is we want to heat up the wire itself. Get it nice and warm. We heat it up on the back side. I can just hold temperature to it, or I just hold temperature on the front side. Doesn't matter how you do it. Then you touch your solder. You can add a little bit to your iron just so it keeps it nice and clean. And then you watch what happens is it wicks into the wire itself. Then you add more solder to the wire, not to the iron. In this kind of cable, you could definitely add it to the iron. It wouldn't hurt nothing. But in bigger wire, it's going to matter a lot. So that's what you don't need to watch out for. That's what you need to watch out for. Midwest, thanks for sharing the live. Appreciate you, man. So next, we're going to connect right here. Hold the heat to it. Add a little bit of solder to the actual iron so you can know when it wicks in. And if you watch, let me do it on the back side. If you watch closely, let me put a little bit of solder right here. It'll wick. You'll see that bubble disappear. So then I can add some more solder. And as I add solder, it slowly sucks in to the entire wire. So we're all soldered all together. There's a little bit on the end right here that's not taking solder for some reason. There may just be some trash on it or something like that. I'll see if I can get it to bond. It worked just fine. I just add a little bit of solder to the tip of the iron. Now, keep the iron wet with solder. And I say wet because solder is liquid when it's hot. It's solid when it's not hot. So wet it with solder because there's liquid solder on there now. line up the connections, figure out how to contort your fingers to hold the two connections together, right? So I can manipulate right here, and I can also put pressure on there. So I put the connection on here and I push it down. I just let it wick into that joint, and I just make sure I have even pressure on the whole thing. And if I want to get fancy, I'll hold it with fingers, try to hold it the best I can, and I'll heat it up some more and add some more solder to it. You have to wait for the solder to dry. Right now it's extremely hot. You would complain and burn your fingers, and you'd be like, I can't hold it. What's going on? If you can't hold it and you can't handle the heat, which I've done this for a long, long time, so I'm used to it, then get a pair of little clips. They've got little alligator clip things that you can grab. It's got a little magnifying glass and some alligator clips on it. You can usually find that at any electronics store or any, I don't know, you can probably buy it off Amazon or something. Something like this is perfectly fine. You can use this little tool right here. I don't remember where this came from. I think it was a Christmas present or some crap. But I could do the same thing if I had the connections close enough together. I'd just scoot this in closer, scoot this in closer right here. I could technically put my soldering iron right there if I really wanted to, but it'd come super close to burning it. I could flip this booger over if I ain't got good eyeballs. I don't know if this will work or not, but whatever. This is just a gimmicky little setup. I'm just showing you anyway. But technically you could clip your wire in right here, clip your wire in right here, tighten all your connections up where it's nice and steady, and then add your solder right there if you can't handle the heat. But I've done it for so long, it's just whatever. It don't bother me none. So I prefer to actually manipulate it with my hands because I can push and put pressure on it better than you can with that tool. Hey, no problem. Hopefully it helps you, man. I do appreciate thanks for the follow, Matthew. If you guys, like I said, got questions, feel free to ask. I don't mind helping you guys out. That's what these videos are. They're more tutorial videos to show you guys how to build coax and stuff. But solder is part of RF, so I don't mind showing you guys how to solder. All right, let's go ahead and get the next one done. Like I said, you guys got more questions? Want to know about RF theory? Want to know about what the heck velocity factor was that we just mentioned earlier? I am in the, I'm above Atlanta, northeast part of Atlanta, northeast part above Atlanta. So that's where I'm out of. I don't typically, I do have a shop, and it is technically a shop that you could come into, but right now it is absolutely nasty. Like, not nasty, but let me just, I don't care. I'm not prideful. I'm not gonna sit there and act like it's a mess. So I have stuff everywhere, not just somewhere, everywhere. So this is the test equipment we've got right here. Some HF rigs up there, some regular, what do you call it, 10-meter rigs right there, an Apache Labs over there. You guys on the screen right here, and there's the fancy little Facebook setup right there. There's some of the equipment, but everywhere, I got stuff everywhere. I just got to find places to put it. I've got racks over there, but I got to get more racks. And then I got a whole nother room full of stuff. So right now I am full. So not to be disrespectful to anybody, but I am not a walk-in business as of right now. Until I can get my shop cleaned up, I will not offer walk-ins. Not to be disrespectful to nobody. It's just, you guys don't have to walk over my junk right now. What do you think about wireless rechargeable soldering guns? So if you look at this iron right here, this is a soldering iron right here. This is an 80-watt soldering iron. So it draws 80 watts. So if I had a rechargeable soldering iron, it's like a pencil, this big, something like that. It's going to have what's called an 18650 battery in it. That battery's got 4,000 milliamp hours of charge. So I'm going to grab something and show you guys something just so you guys can see it. Give me just 1 second to find it. I got to figure out where the heck I put it. It's another soldering iron, so you guys will enjoy that. But I got to find it real quick. Where did I put it over here? Let me grab it. So that is not my soldering iron. That is my Dremel tool set. Whatever. It's a battery-powered soldering iron. It is not in this room over here. So I currently own 2 of those right now, but I do off-site jobs and I take those with me. But if you just take my word for it, Ryobi makes a battery-powered soldering iron setup. I have 2 of them. I don't know where they're at, so whatever, it is what it is. I got my little one over there at least to show you? But those have a big enough battery. The problem with the little pin ones is that the battery's not large enough. If you're drawing 80 watts of power and you've got 4,000 milliamp hours at 4 volts, that puts you at 16 watt hours. 16 watt hours, if you're drawing 80 watts out of 16 watt hours, you've got maybe, what, 15 minutes of usage. The problem, and that's if everything works. Is the cup still holding water? Yeah, it didn't leak, it just evaporated, but yeah, it's still holding. Look, Grease Monkey, we did some plastic welding the other day. I used a zip tie as filler material because that's what Grease Monkey said to use, and it worked. Yeah, it's still holding water just fine. Well, no, it's dripping a little bit. So, a little bit of drip at the bottom, but I can always fix it later. That was our little temporary fix. Copy the Milwaukee iron. TikTok is faster, watching both feeds. Copy that for sure. That's cool. Yeah, TikTok is usually about, I don't know, 5-10 second delay or something like that, where Facebook is like 30 or 40 seconds. YouTube's pretty good. They're like 5 or 10 seconds most of the time. Now, Milwaukee iron's fine. It's got a big enough. They use 3 18650s. So if you look at your 12 watt, 12 volt, 2 amp hour, that is 24 watt hours. 24 watt hours out of an 80 watt iron means you got at least 20 minutes worth of charge out of an 80 watt soldering iron. But they don't use a 80 watt pencil, they use a 40 watt pencil. So if they use a 40 watt pencil and they're using 24 watt hours, that means you got a little over 30 minutes of usage. If you get a 4 amp hour battery, then of course it lasts for an hour. That would be the usage of your soldering iron. Typically most soldering iron jobs only take about 5 or 10 minutes. So the pins are a little gimmicky until the battery technology gets way better than what it is, just so you guys know. That's a little bit of math for you guys broken down to explain why we don't have pocket soldering irons right now, not super small. It's because the wattage draw is a little bit too high. There's one advertising to be 100 watts out there, but the problem is the battery capacity is just not there to be able to put out 100 watts. If you get a 18650, some of the best 18650s can do what's called 20C rate of discharge. So that means they can discharge about 20 times their power for very limited times. So if you did something like that on a 4x4 16 watt hour and it did 20 times its power, it could definitely exceed 100 watts, but for a very, very short period of time. And the problem is you wouldn't be able to recharge it fast enough. It would just draw power and kill itself super fast. So 40 watt pencil, 16 watt iron, maybe in the future the little pocket pencils will work if you can find a battery that's not going to get overheated from drawing too much power, because all batteries have something called internal resistance. The more wattage you pull through them, the hotter they get. Sorry, we're going to get into some nerdy stuff if we start talking about why they don't have certain technologies out there. So, forgive me. Yeah, it's cool for sure. It uses lithium ion 18650s for the batteries, and it's 2 amp hours at 12 volts. So it's 3 batteries in series up to a 12 volt circuit. So most of your this one right here is a 24 volt iron, and it uses 80 watts. So if I turn it off right now, and I'll just show you guys on the video real quick. When we put some water on it, we get it nice and cool. So now it is below 200 degrees at the absolute minimum, if not closer to a little lower than that. So we're below 200 degrees. We're going to turn it on when I count. Flip it on. 1, 2, 3. Oh, I'm sorry. It's burning the water off. 1, 2, 3, 4, 5. I'm already solder temperature now. 6, 7, 8 seconds. About 8 seconds to get up to its full temperature with an 80 watt iron. So that's a lot of power it has to draw for that short amount of time. So gives you an idea. So it'll solder at about 4 seconds, and it'll be up to the proper temperature at about 8 seconds. I have an iron that's actually faster than that, believe it or not. I have about it's a lot of money, let's just say. It's about $3,000 for it's $2,000 for the power supply. 270 for that, 46 for that, 380 for that one, I think, and then 40 for that. I don't know, about $3,000 worth of soldering iron set up. It heats up really fast. But that is Metcal way better. Metcal. I'm not familiar with Metcal. I deal with, are you talking about soldering irons? The soldering irons I use are Weller. Heiko is also a good soldering iron that's been used for a lot of years. They've been around for a long time. Weller is generally the gold standard in soldering irons for pretty much anybody who solders. The company that owns them now, I'm not a huge fan of, but they are very, very nice. They make a bunch of off-brand soldering irons. I don't know, probably well over about 4,000 or 5,000 different companies make them. So I'm sure there may be some good companies out there nowadays, especially with lithium technology getting better now. But I am kind of OG into the Weller community. Been there for a long time, way before they got bought out. So definitely nice. So now I have multiple irons that have smart irons. They will control. They will go back to their settings that they're set at. But I have a big power supply over there. So my power supply is a couple hundred watts. So I can run an 80 watt pencil and a 120 watt pencil at the same time and do multiple jobs. So that's typically what I do. So it gets me a lot of other options. The power supply I have at the shop is at my other business is about 400 watts, and I have about 3 of those. So the power supply itself, two of those. And then I have another smaller one that's not quite that much. I think it's 320 watts or something like that. The power supply. That's not the tips. The tips I got are like micro soldering iron tips for surface mount. So I have micro tweezers, I have micro soldering irons, and I also have my big tips for my big jobs. Biggest iron I got is 150 watts, and the smallest iron I got is 40 watts. The smallest tip I have is 0.4 millimeters across. The largest tip I have is, I think, 4 millimeters across, something like that. I don't get into the old stained glass stuff where they have 4 and 5 and 600 watt pencils. Solder I use is Kester. That's what I will use. Kester is kind of it's also the OG. It's been around for years. It's the best company to buy solder from. Now you're going to pay about $50 a spool for it, so be prepared to hurt your pocketbook every time you buy a pound of solder. But yeah. Sorry I didn't respond to your question earlier, Stephen. I did not get there. I didn't see it. So we're soldering right now. Bond into this body right here. Technically, if I had about, I would say about 150 watt pencil, I wouldn't have to have the torch. But I still like to use the torch because it heats up that connection extremely fast, and it keeps it from wicking so much heat down into the wire. Not that it really matters too much, because this wire can handle it, but I just like to have good practice and keep my thermal control to a very limited area, so I'm not adding a whole lot of heat way up the wire. One, because it makes it easier for me to handle too. The other reason is just to be easier on the wire. So what I'll use a lot of times is 6337 or 6040 rosin core. Yes, so that's what I'll use a lot of times. Have you used solder ICA cells? Supposedly the old Radio Shack branded solder. I think I've used it before. It does fine. I have no problems with it. No, personally, I'm not going to stick with it just because I am sold on Kester. It's worked well for me. Done a great job. It's bonded to joints that I didn't think would bond. It's cleaned up connections that I didn't think would clean. Like, there's a lot of benefits for the Kester. So I'm a big fan of that one. Thank you for liking the live, guys. Thank you for tapping the screen. It is appreciated for sure. And if you guys like the content, feel free to follow me. Or subscribe over there on YouTube. But yeah, I appreciate all you guys. Yeah, it's just trying to check all these chats. So right now, unfortunately, TikTok has been a pain in my neck. So if you guys on TikTok saw that little camera setup that I got, it's a fancy gimbal. It's a the RS4 Mini DJI gimbal, and it's all on a setup right here. So you guys on Facebook can't really see what it is because you guys are the ones on it. But it's for me whenever I go, like I'm going to Gulfport, not this next weekend to go into a key down. So whenever I go to those events, I like to try to have the best camera that I can for you guys. And I also have like a whole computer set up on here too. That way I can go live on Facebook, YouTube, TikTok, Twitch, and X, I believe, is the platforms I go live on. Whenever I do that, it works great. But TikTok it doesn't like it for some reason. I don't know why. I'm still able to go live. It never bans me from going live, but it stops me from being able to go live on the RTMP, whatever it's called. It's the remote something protocol. And I don't know. Like I said, it just keeps kicking me off and putting me back on a phone. So I'm about to a point where I'm going to go back to a simpler setup. Even though this is significantly more expensive, I've got to have something that's simpler and easy to use. Because I was trying to avoid walking around like a dummy with two gimbals and two phones in my hands to try to go live on Facebook, YouTube, and TikTok at the same time. I could do Facebook and YouTube together, but I can't. TikTok just decides it wants to jump off from the pack. So I found something that allows me to do it, and now it's just too gimmicky. It just won't work. For some reason, TikTok doesn't like it. If anybody could tell me why, that would be great, but I've yet to find anybody to explain it to me. Even the people in customer service at TikTok have no clue. They're just like, well, wait till your thingy's over and try it again. I'm like, okay, thanks. I've done that like 6 times. All right, so what we're doing right here is, like I said, soldering some more wire. We'll talk more about some coax and not about stupid streaming, because you guys don't like that. A buddy of mine has a boatload of Kester solder he scored from an auction. Well, send some my way. I'll take it. Kester's great. It's good stuff. So we'll heat up the torch, light out this connection. All right. I did not pay attention. I should have paid attention, but I did not. All right, so I know, right? Still got a bunch of guys on YouTube. Hello, YouTube. Hope you guys are doing well. I don't see you guys commenting over there, but thank you guys for hanging out. Last person who commented over there is Audio Smith. Sometimes YouTube just gets quiet. You guys on Facebook or on TikTok are great. You guys will hang out and see what's going on, talk about it, and all kinds of other stuff. But daggum YouTube over there, they're great. I ain't got no problems with them. You can watch all they want, but they will not say a dang thing, man. I was actually surprised. I got like 30 or 40 people commenting on there earlier. That's or 30 or 40 comments in there earlier. I can have 100 people in YouTube, and I'll get like, I don't know, 3 of them maybe commenting. It's crazy. TikTok, you guys are cool. You guys will say stuff. Now, that's not saying you guys on YouTube are not cool. Please don't think I'm being mean to you guys. You guys are great. I think I got a lot of people this time of night that'll hop in from Saudi Arabia and stuff. So I've got several guys on the amateur world that will hop in there and watch my stuff from over there. I actually had one in there earlier. A fella told me I couldn't translate it. I was trying to translate it, but they said he was saying hello, and it was Persian. So I guess he was from Pakistan or possibly Iran. Who knows? All right, questions, guys. Questions. Feel free to ask. We're working on some. If you've ever been on an airplane, you've probably been around this wire before, because this wire is run all over the airplane. Typically towards the cockpit, but still. Same concept. It'll have to go out to the antennas, wherever they have the antennas at. Great Spunky! What's up, man? Appreciate you, man. Yeah, over there not saying nothing. I see how you are. Nah, I appreciate you, man. Thanks for hanging out. YouTube's starting to get better. I think I've got 500 and something people on YouTube, but I got like 3,000 or 4,000 on. Now, I'm an RF company. Don't think I'm some influencer or some bullcrap. So D-Win's RF Supply is what I am. For RF community, where the community's maybe, I don't know, 30,000 in some respects, and a super wide, broad audience, maybe about 1 million total. Having between all the platforms I got, like maybe, was it 5, 8, maybe 9,000 now. I'm not doing too bad for my niche community. Now, if I get into the rest of the community, 1 million would be about maxed out. That would be the most amount of people that will ever follow me for RF stuff, unless I get more people into it. So that would be like 10 years down the line, every single person on the planet that does communication stuff, maybe I might get 1 million. So I'm very happy with the amount of people that hang out and follow. I appreciate all you guys. So you guys are great. I don't need to have this gigantic freaking, I don't know, following of people who just don't know what I'm doing, or not don't know what I'm doing, but who don't care about what I'm doing. They just want to watch a funny video or something. So I hope you guys find this stuff interesting. Hope you guys want to know more about it. Like I said, this stuff is RF coax. It's used to transfer RF signals. If you got a cell phone, if you've got if you've been in an airplane before, if you got Wi-Fi at your house, chances are you've used coax before, or you've got coax in use at your around you before. So it's transferring radio signals all over the place. So you got AM signals, you got FM signals, you've got TV signals for the new TV, the digital TV stuff. Even the old school TV stuff was signals too. You've got MRI equipment. It uses coax, and it uses things like this. This is a water-cooled tube right here. This stuff is not. This is a lot larger than what's used in the MRI machines and stuff. Then your CAT scans and stuff like that use RF equipment too. A lot of times. That's how they shoot their imaging. They use radio signals. All right, this is all finished on this one, and then I'm going to grab another one, and then we will call it for sure. Thanks, John. Appreciate you following. I do appreciate you. Hope you're enjoying the videos. If you guys are liking what you're seeing or you want to know more about it, feel free to tap the screen, and hopefully it will show you some more of my videos. I've got some videos out there, some crazy stuff with RF. I've got Suburbans with like 8 and 10 or 11 alternators, literally revving up to 5,000 to 6,000 RPMs, turning alternators into 3-phase generators in order to do like an RF competition. So these guys are, they call it a key down. I'm going to one of those next week, and you guys will get to see that stuff. I think that is a pretty neat way to introduce people to the RF world. They'll hear antennas to avionics rack. Yes, sir. I need to go up to YouTube and wake them up. I know, right? Nah, you're doing good. Thank you, man. Appreciate you. Facebook's actually, I don't know if it's the, what do you call it? If it's just the thing not updating me properly. If it is not if it's true, that's that's wild, man. I don't have a. Is it just you in there over there, Steven, on Facebook? Sometimes it don't update me right. It doesn't tell me the right number. But if it's just one in Facebook, that's wild. Because the Facebook's actually where I have the most followers. My live got killed on freaking... This is literally the second time that's happened today. Whatever.
Are you scrolling instead of sleeping?
I'm going to go live again. Who cares? I'm about to end it in a minute, though. Maybe they'll find me again. It's too late for me to be doing live because I keep freaking... you can tell whenever you slow down and stuff and you don't get things done as quickly. And I am finding myself... What are you doing? Killing me over here. Let me just click this right here. And then click that live right there. Maybe they'll go back and look for me and find me. But yeah, it killed the live again, but whatever. So, yeah, I'm working on some RG400, guys. If you guys dealt with coax before or ever been in an airplane, you've probably seen this stuff, or probably been around this stuff. Might not seen it because it's behind all the panels. Working on some RG400 coax right now. What's up, Fishy? What's up, Sylvester? What's up, Keith? What's up, Sasha? Hope you guys are doing well. Shows three in it. Okay, cool. Oh, yeah, I know, Grease Monkey. There's a stupid. I'm going to buy it now. It's literally bit me in the butt too many times. There's a little screen mirroring thing that I can get. It's a little screen I can put up right here. It shows me the chat that's going on in TikTok, and also it'll show me the stupid puzzle when it pops up, and then I can hop up within 5 minutes and pass the puzzle, and it doesn't have to kill my live like it just did a while ago. So. That's, ugh. That was a good live too. Had a bunch of people in there, man. Had like 70-something people in there a while ago. All right, so now trying to get as many of these things done as possible. I'm trying to finish a bunch of orders before I go down to Gulfport, Mississippi. What's up, PC Repair Techs? What's up, John? What's up, Marcio? What's up, DefMech? Christian, Freedom Room to Travel. What's up, guys? Hope you guys are having a good evening tonight. On your doom scroll on TikTok. Maybe I'll be your... freaking Whiskey Man on Facebook told me, he's like, yeah, your lives are great, man. They put me to sleep every time. I'm like, you butthole. So apparently, to some, my voice is soothing and will help put you to sleep. Oh, Lord. But yeah, that was freaking Whiskey Man for you. YouTube has better quality also. Okay, well, that's good to know. YouTube and Facebook is the same hookup, so that's pretty interesting to know. What's up, Felipe? What's up? What's up, guys? Hope you guys are doing well. Kevin, Philip, Dave, Rudy. Hope you guys are having a good day. Carlos, hello, hello. Right now, we are working on some RG400. What's up, Don Cook, Dwoozy, Gigglefart, Myrtle? What's up, guys? Hope you guys are having a good evening today. We're working on some RG400 coaxial cable. If you've ever been in an airplane, you've seen this stuff before. So, or not seen this stuff before. You've been around this stuff before. This is commonly used in aviation and aeronautics. I am repeating this because my live went dead and I lost everybody that was in it because I didn't pass the stupid puzzle. So, hope you guys are having a good day. I'm going to show you guys how to solder if you guys look closely. I got a bunch of guys in YouTube land. It's not telling me the truth over there. I got a lot more in YouTube than I thought. So, appreciate you guys. Hope you guys are having a great day over on YouTube. So, we're working on, like I said, some RG400. I've currently been live. How long have I been live for? It told me earlier. It showed it. Whatever. I don't know. But we're soldering the center conductor and get this thing all bonded up. If you guys like the video, definitely feel free to tap the screen if you don't mind, because TikTok apparently decides that you don't like my video if you don't tap the screen. So it ain't like you can go on Facebook and tap it one time. It wants you to tap it a bunch. But thank you guys for hanging out and checking out the video. We're working on, like I said, some coax cable. About to hit a torch on this real quick and get it nice and hot to bond and wick the solder into this joint. So I got a little bit of residual solder on there, and we want that solder to wick in to make sure we hit the right temperature, and we're going to use the torch to do it. We're going to heat it up until we watch that braid wick into that joint. So it's still nice and solid. It's changing a little bit, moving just a smidge, and it is now wicking in. So now it's up to the proper temperature to wick. So what I use is the soldering iron and wick it into the joint. I use the torch like a little preheater, since this is a double braided silver plated copper shield. It has a lot of thermal conductivity. So what it does is it'll wick a lot of that heat up into the wire itself and steal it from the end of this connection right here. So gets on my nerves and is a pain in the neck sometimes. What's up, Billy? What's up, Frank? What's up, Dog? What's up, Dre? What's up, John, Roblo, and David? That's not everybody, of course, but if I see your name, I'll try to say hello to you. Mo, Trusty, whoever else is hopping in and out. I hope you guys are having a good day. I wish I could see the same thing on like YouTube and stuff so I could say hello to them too. But I don't see YouTube unless you guys comment. Yeah, it says 31 right now on mine. Copy the 20 over there, Grease Monkey. Thanks for letting me know. It says 23 on my other screen, but it says 31 on this screen. So it's... All right. We got 40 over there on TikTok land. 39 at least. What? Comments were filtered. You guys better watch your mouth over there. Don't be having no potty mouth on my daggum stream. All right, so we're showing you guys how to solder this wire. We got it all nice and bonded up here. We bonded all the holes, and this connector is now one piece with this wire. We terminated it properly. Super Chalice, hello. Hope you're doing well, man. Thank you for the sunglasses. All right, so what we've currently worked on today, we've worked on RG400, we've worked on more RG400, and more RG400, and more RG400, and we've already finished that one. That was a different one. Never mind. And then more RG400, and then more right here, and then more right here. And then earlier, before this, we were working on some other wire. This is 1/2 inch hardline right here. I'm going to zoom out just a smidge on TikTok. Hopefully that zoomed properly so you guys can see what this wire looks like. This is a 7/8 EIA connector right here. This is a 7/8 EIA split feed. I'm going to zoom out for YouTube and Facebook land right here. This is what we've been working on today, and this is what we set up. This is the termination for this connection right here, and then of course it's got EIAs all the way throughout. I also have bird meters and stuff like that I'm working on. I'll be working on them soon. If you guys want anything, it's dwinsrfsupply.com. Next, I'm not going to be able to do it tonight, but I'm going to try. Actually, I don't know. We might do it. Let's see. So right here is a power supply. I've got 2 of these I've got to build for a customer. I don't know if I want to try to do this right. I'm going to do it. Whatever. Screw it. Let's get some work done. So I'm going to show you guys how to modify these power supplies. So this is going to be when I'm done with it, about a 14-volt power supply. I don't need that. That don't matter. So pull this one out right here. All right. So we're changing up gears a little bit. Maybe you guys like it. Maybe you guys don't. If enough of you guys want to see it, I will do it on the live. If you guys decide that you don't and you bail on me, I will not be motivated to finish. Just being quite honest. So as long as you guys stick around, I'll do it. So I'm going to zoom in real quick so you guys can see what we're doing real quick. We're working on some power supplies, like I said. So these are going to be modified. Let me get back off of this stupid view right here. We're zoomed in a little too much. That's fine. Should be good. YouTube and Facebook's fine right there. So I guess we can show you guys a little bit of surface mount work. I'm not technically pulling any surface mount parts off, but it is the same size solder pads as is on a surface mount circuit. So you guys will get to see that and how that works here shortly. So there is a motherboard, a daughter board, and a few other parts and components on this circuit. This converts AC power into DC power. That's what this is. It is a retired server power supply. So it's going to be repurposed as an aftermarket power supply. Crab, hello, hello. Topeka Dave, waving a hand. Taylor, waving a hand. Hope you guys are doing well. Thanks for the hearts. Thank you guys for, hey, I got a fan club. That's cool. Whatever a fan club is, thank you, thank you. All right, so on my business card, what do you say on my business card? D1. Yeah, D1 clear on YouTube. I screenshot each one, but won't let me send you the pitch on Facebook Messenger. So, if you go right here, I don't know. It won't let me, if you don't let you send me pictures on Facebook, that's not freaking whatever. dwinsrfsupply.com. If you want to send it to my email, Grease Monkey, you can. It's dwinsrfsupply@gmail.com. Literally everything I have is dwinsrfsupply. So it don't matter what it is. If there's something out there, if you want to check for me on Twitch or on X or on something else, it's dwinsrfsupply. If you want to find me on something else, it's going to be dwinsrfsupply. So that is my business. So I got some parts right here. We're going to get to work. So this is a 6-watt component that I use right here. You can use something else if you wanted to, but this is what I choose to use just because I like it. It's easy to use and it works for me. So if you look right here, there's a daughter board over here, and what I'm going to be doing is I'm going to be tricking this daughter board into thinking the voltage is dropping, and it's going to boost the voltage. And it's just going to be a constant operation where it boosts it. So if you don't watch it, there is a crowbar circuit in here that will get tripped and will get modified, and will get messed up if it does not read properly. So if you go on some old RC car forums, they explain this a lot on a lot of these server supplies on how to modify them. So if you guys want to reference that, feel free to go there. Not saying that I'm not willing to show you guys, but there's differences for every single supply you get. But yeah, thanks for the follow. Appreciate you, George. Appreciate you, Andy. Thanks for the follow too. You guys are awesome. I hope you guys are enjoying the video. So what we're doing right here is we're going from this variable over to this circuit over here. So if you look closely, I'll show you guys on TikTok how small these parts are. So there's going to be something that happens to my soldering iron that I'm going to have to modify. So zoom, zoom, zoom. Bump the camera over just a smidge. But this gives you an idea of the components. You guys are going to love that on TikTok. You guys will see exactly what part I'm moving. So I don't hurt my feelings at all. I don't care. Now, Facebook and YouTube, I apologize. I can only get so far because I have a lens on this thing, and I think it's like 20-something millimeter or something like that. So it's only got so much zoom. So Sorry. If you want to see better, go to TikTok. So let me grab a smaller tip. So if you look at my big old gigantic tip, it is entirely too large to work on those circuits. So it is too big. So it will not work. So what I'm going to do is do something kind of dumb for you guys that don't do this, don't copy me. I'm changing it out while it's still hot, but what you guys want to do is turn it off and make sure the iron is nice and cool before you swap out your tip. I don't very often do that, but whatever. That's what I get for doing it at 3 in the morning. So it didn't burn me or nothing, thank God. But it is always better to be safe rather than make a mistake. So do as I say, not as I do, just simply because I'm trying to hurry and finish this project. This is a last minute project that I've got to get done, hopefully before the weekend's out. There we go, tips out. The cool thing about this bench is it can handle the heat with no problems. We will change up our tip real quick. All right, there we go. So now this has got a very small tip right here on the end of this soldering iron, and we're gonna line it up. So I need the end of the iron. I'll grab that in just a second. Let me grab this real quick. Let me scrape. Where is this at? Scrape, scrape. So typically if I get any sort of damage to my skin, I can't show you guys this on video just simply because TikTok will kick me off or whatever. But what I'll do, if I have any sort of burns at all, even surface level burns, and I got through a callus or something like that, I'll make sure and I'll scrape it with a knife. That way I knock any sort of burnt skin off. I don't really have anything right now, so luckily I'm good. But I always do that to be safe. But like I said, I can't do that on video. But that is my advice. I'm not one to let it blister up or any bullcrap like that. So we don't do that, Doc. So let's go ahead and add some solder and let's get to work. You guys bailed on me. They didn't want to see it. So I've got to let this thing heat up. Give me just a second. Get this lined up. And then let me grab something right here. Hopefully I don't mess up and not message my peoples. If you guys got questions while we're working on this, if you want to know what the heck this is, I am happy to explain it to you guys. It does not hurt my feelings at all. Feel free to ask. If you guys want to talk about RF stuff, we can talk about RF stuff. If you guys want to talk about power supplies, we can talk about power supplies. Like I said, none of that stuff bothers me at all. We can talk about whatever. I got to respond right here. Whatever. I'll respond later. Let's pick up my resistor. So now what I'm going to do, line this up right here. We'll bend this into place. We've got a nice little pair of tweezers we're going to use. This power supply is going to be for a DC supply. It's going to be used for anything that requires around 14 volts. So it can be used for anything. Anything that you would normally use in a car, you can now use in a home application. A lot of guys will use it for RC car battery chargers. They'll use it for technically you could get into using stuff like this for certain type of like FPV drone chargers and stuff like that. There's a lot of different things you could use it for. But it is a simple 80 amp power supply that can be used in, like I said, a home application. So, watch y'all. we're going to go ahead and add some solder to our joint real quick that we're soldering to. I've got to get a little bit more particular with my solder, so I'm going to throw some stuff out of my way so I can actually work. I know that you're tricking it, but what for? I'm tricking it. It's normally a 12-volt supply, so it's normally a server supply that holds 12.1 to 12.6 volts, and it does not move, nor does it change. So I'm going into the daughter board, and I'm tricking that daughter board into thinking the voltage is dropping, and telling it to boost the voltage. So it is made extremely durable, extremely well, designed for 24/7 use, 365 days a year with no breaks. So if I can get it to work at the intended voltage that I want it to work at smoothly and safely, then that is very, very nice. So you can typically go up to about 14.5, 14.7 or so volts in a stable way. You can go beyond that, upwards of about 16 volts in an unstable way. It does dump voltage a lot more and doesn't handle as much current. I typically will not go up that high, not unless somebody just had to have it up that high. The capacitors, the filter caps in this unit are only good for 15 volts, so you do not want to exceed, or excuse me, 16 volts. So you do not want to exceed 16 volts, no matter how high you go, unless you're going to change the filter caps. So I have some angel hair solder, and sometimes you'll catch me using that on this job, but as of now, I don't think I'm going to have to use it. So there's multiple traces in here. I have to watch out for it, make sure I don't touch off on any traces that I'm not trying to contact. And then, of course, I've got to all right, solder is bonded. The way I can tell that is I take this joint and I'll tug on it pretty good and make sure it doesn't come loose. It is a risk that I could damage the trace by doing that, but I always test it anyway just to make sure it's going to hold up. So, a little more in the soldering. So, how to solder? Is that what you'd like to know a little bit more of? Or what am I soldering? So, what's the question that you would like me to answer? So let's get some heat shrink. We need some of this stuff. See if I can use that. If I can, I'll go to the next size up. So we'll straighten that out temporarily. Yes, how to solder. So the way you solder on any solder joint, the way it's going to work, give me just 1 second. Let me line this heat shrink up real quick. Is you apply heat to the actual connection point. You do not apply heat to the solder. And you do not touch the solder over and over to the iron. You also do not touch the iron over and over to the source. You hold the soldering iron on the source. You apply the solder to the source whenever it gets hot enough until it wicks into the joint. You'll watch it wick in. So you can also wet the tip of the soldering iron to keep it nice and clean, to also clean up the joint and stuff like that. So there's a little bit more nuance to soldering when it comes to dirty connections and things like that. So do keep in mind you will have to kind of clean up the joint, maybe waste a little bit of solder and then go back to it again. But that's the basic concept of soldering though. I would like to only use my freaking lighter, but my lighter's dead and out of butane. And I am not going to run and dig around for another iron or another lighter. So what I'm going to do is something entirely overkill and use a torch to heat up this small piece of heat shrink. But luckily for you guys and myself, I have a little adjustment on there. So I don't have to have it so crazy hot. But still, it's plenty hot. It boogered heat shrunk right away. So that connection is finished. Now from this point, we want to go to our other connection here. So I may have to redo this because it's 3 in the morning, 4 in the morning, and I may have something backwards, but we will cross that bridge in a moment. I don't have anything backwards as far as connection. I just may have the wrong circuit hooked up. So you guys can mostly see right here. I think maybe it is not the best angle, but I'll give you guys the best I can. Leonard, thanks for the follow. Appreciate you, man. What are you doing up? Go to bed. All right, so next we got this right here. All right, we're bonded to that joint. Next, we need to go ahead and cut this to piece on the business card. Yeah, I don't know what you said. Still not quite catching what you were saying, Grease Monkey. I apologize. It's been a minute. So, back to what I was doing. Next is right here. So we got to measure right here. This is the last connection for the night because I do see the time. So I am going to call it at this. This fella is a really good guy. I like him. He's a cool guy. But I'm going to try to see if I can do something maybe for him tomorrow because he needs it by this weekend if possible. So I'll see what I can do for him. All right. Thanks, Taylor. I think I already told you, but thanks for the follow. I appreciate you. Soldering this last one over here. So what you want to do is pretend your actual. Can you guys see very well right there? Where is that? Is that the right angle? Yeah, that's good enough. So you want to pretend your connection. So you want to have some solder already bonded onto the actual piece you're trying to bond on. And then you want to make sure you control the amount of solder you use. Just keep it reasonable. Make sure you're not using a lot of solder and wasting and bubbling up the joint too much. Because if you are, then what's going to happen is you'll end up having a connection get shorted because you used too much solder. Speaking of that, I'm going to knock some off of this. I've already got a bit of bubble already on this joint right here. All right. So questions, guys. You guys want to know things, y'all feel free to ask me. It does not hurt my feelings for me to talk about it. Whatever. I'll deal with it later. So now we're going to grab a little piece. Do I know anything about EEPROMs? Unfortunately, I know a little bit about EEPROMs that I don't want to know. I'm trying to do an EEPROM for a 1993 Chevy GMC with a 350 motor and a 4L60E, or 4L80E, excuse me. So I've got a guy that's supposed to be doing an EEPROM for me, and unfortunately he has taken my money. So, yeah, that's my knowledge on them. So no, I don't really know a lot about them. When it gets into the software stuff, I understand the software stuff, but I do not try to get into it because it's just not my field. I deal with component level stuff a lot of times. All right, this is the end. So we're adding some solder to the back side of this joint right here. Make sure it bonds in and grabs what it needs to do. And then we're going to take this small connection right here and we're going to connect it to the bonded connection right over here on the other side, because it pokes through as a through-hole component. All right, we are all connected. So if I want to get fancy with it and I don't have a soldering iron, what I'm going to do, or excuse me, don't have a good lighter, I'm just going to use the heat from my soldering iron after it's got everything cleaned off of it. There is no solder on it at all. Make sure it stays nice and clean. And I just use it to heat my heat shrink down. So that connection is done. That is how you solder to a circuit board. All right, guys, I am out. Appreciate you, Jim. Thanks for the follow. If you guys want to see more of my stuff, feel free to like the video. Maybe it'll show you some more of my content. If you guys like it enough, feel free to follow me or subscribe. Thank you, thank you. You guys have an excellent evening, and I will talk to you guys later. See y'all. Thanks, TikTok. Appreciate y'all, guys. All right, and then for Facebook and everything else. So we'll click the fancy screen for you guys. Since we can, might as well. Just click over here. Oh man, it's froze. Whatever. All right, see you guys later. I can click it right there. Let's do ending. Where's the ending? Bam.